Good afternoon. I announced it in the other video that I'm going to be doing a tutorial or multiple tutorials on the entire OBD1, OBD2 diagnostic systems with the CAN bus on how this actually works. And I thought for the introduction to this whole thing, I'm going to start with the very early models, which had the first diagnostic or enhanced diagnostic systems. And as you can see here, is I pulled up the DTC manual for the M119 engine for the 400 4-liter engines, 4.2 and 5-liter engines, and 4.2 and 5.0 engines, which were manufactured basically between 1992 to 1995. And this would apply also for the 600 SEL, which is very similar to this here, but I think there's probably more people out there who may have a 5-liter engines or the 4.2-liter engines rather than the V12s. This does not concern the AMG models. They're a little bit different, but they weren't really as prevalent at that time. In order to understand now the diagnostics of the 140, the 202, and then the later versions of the 124s, which had the similar system, is that the to introduce this, to understand this better, we have to go actually back to the original 126, the W126 4.2 5.6 liter, the R107, and that also applies of course to the R129, to the R107 of the later models, when they did the Modellpflege, as we call it in Germany. That means when they come out with the enhanced or newer versions of it, like they did with the 126s in the mid-80s, in 85, 86. Das war eine Modellpflege, that's what they call it. I don't really know if there's it wasn't a model change. It was like an upgrade from version 1.0 to version 2.0 or something like this. Sometimes they were bigger, sometimes they were smaller. So I guess most viewers hopefully are acquainted with these 3-pin diagnostic units with the light on it, and you plug them in. I got this one here from Rick's. He is here in Kansas, and I bought that a year and a half ago when I got the car. And this thing works pretty well. Mercedes codereader.com. I think I bought this on eBay from him for 29 bucks. I can't remember with or without shipping. I think they're now 40 bucks. But this was the precursor for everything what came. And this is what I have seen on the messaging boards, bensworld.org and those places. And to a certain extent, the message boards they have on Pelican Parts and other places, where people are utterly confused now if you can do only the blink test, or if you can do actually more, if you can get more engine data out of it. And this is what we're going to be talking about it. There was the beginning of the ISO 9. Now I gotta look. I can't remember all of the stuff. Let me see. This goes now back a long time ago, so long that I can't remember this. This was the ISO 9141. This is the standard which evolved out of this system here. And then from, oops, now I closed these models here, the early models between 92 and 95, because I believe in 95 and 96, this ISO standard here was introduced, at ISO 9141. And the ISO standard itself, I don't want to bore you with data sheets of electronic components, but I had to refresh my memory because it was a long time ago since I worked with this stuff. The pulse output usually originates on these units here on the yellow wire. And the red wire is connected to the battery, and the black one is connected to the diagnostic socket. Usually they have a ground pin. In this thing, usually you clamp onto your car battery, and the yellow one goes into the socket for the corresponding module you want to test. And in the late 80s, when I got involved into this here was originally only a, how should I say this, only a one-directional signal. So you would start this by pushing the button for 2 seconds, 2 to 3 seconds. That woke up the controller that we wanted communication, and then the controller starts to put a signal out. But this unit really couldn't talk to the controller or to the module you wanted to talk to, except for 2 instructions. 2 seconds to 3 seconds is basically give me the code. And if you go 8 to 10 seconds, then you're telling him reset the code. So it is sort of a bidirectional communication, but it is very, very limited, because the function of the switch will pull this line, which is usually at battery voltage, whatever your battery voltage is, which would be around 12 volts, hopefully, to 14.2 or whatever the charge state is. And by pushing this one here, you're basically grounding this pin. And when this pin goes from a high signal, in that case, the battery voltage, I'm not saying 12 volt, because people watch this and then they think they have to have 12 volt on there. It is whatever the battery is putting out at this point and moment when you have turned on your ignition. That's why that is called only the battery signal voltage is the high level. So when you push this, the LED comes on and it pulls this pin down to ground to the chassis. And that indicates now that transition from high to low, and then the release tells the control module or the module in question to be tested that we want to see something here if there's anything there. And we know that if it puts out a 1, then everything is hunky-dunky-dory. He doesn't know anything. And if he has codes, they're coming then out one after another. So it puts out the lowest, it starts with the lowest blink number and works its way up, and you got to sit there with a piece of paper to write it down. And then when you push this button again for 2 or 3 seconds, it will put the first code out. Then when that brief break comes, then you have to push immediately to reset it if you want to clear it. And then you have to clear out each code as they come. Depends on how many codes you have. It's a pretty time-consuming process. But since this was sort of a bidirectional signal already, we figured back then we could enhance this. And we can actually talk between the 2 units when you have a microcontroller-based unit. And this is how we came up. First of all, Mercedes-Benz asked a company, again, near Stuttgart. I was not involved with this here, but this is basically this tester here, which has the convenience of an LC display. So instead of you sitting there counting LED pulses or blinks, it will count that for you. And then when the break, if there's multiple error codes coming, then it will erase the error code and it starts up with the new. So you still have to sit there and write it all down. It never did all of them, kept them, like wrote them down in sequence. So, and I thought, well, this thing is really a no-brainer. And as you can see, this is basically the box here. This is what a empty chassis looks like for those. This one has the option of putting actually a battery in there, which we wouldn't need. So I'm going to build one of those, because I'm tired of it, but I'm going to have them write down all the codes which are coming. And then if there's only one code, it will give you the number, and then it says end. And then it will stay there until the next time the button is pushed. And I'm going to do a start. They have a start button, and I'm going to do a separate reset button, start button and reset button. And the battery, that the green light basically blinks, so you can either read it or not. they still have, Mercedes-Benz still have this, has this system, this tester, Impulszähler, means a pulse counter, in their catalog, and under this part number, and I believe this is over 2,000 euro, because the company in Ludwigsburg, it's a little bit outside of Ludwigsburg, still makes them. And you can order that, and they have to custom make this, so that's why that is so expensive. That's but this was basically the enhanced version of the blink unit. If we build something like this here, you know, if I have it made in China, they're probably gonna retail for about $50. That's what this is gonna come out to. But this LC display would be a 2-line LC display with a backlight, so you can actually read this better. And it would have the clamp on it for the 12-volt battery, and the yellow and the black wire to plug in. And then 2 buttons. I would say $50 with the chassis. This here is a surplus chassis I got from a company here in Missouri. They used to make this thing here. They built it for some customer, and they went out of business a couple of years ago. They couldn't survive the onslaught from the Chinese, so I can get like 10,000 of these. They were made here in the United States in the 2000s. This is all American made in Missouri, so we can build this actually up here. So I'm going to build 1 unit, and then when that is done in a couple months or so, depending on how I got time, I got other things to do, I'm going to show you that on my car, on how this actually works with the reader. Then we have to simulate some codes, disconnect some stuff from the ECU as they come on, and this will also display the codes basically. If you go into diagnostic mode, we probably can incorporate this to do the pulse, what the pulse unit does when the engine actually is running, to show you the percentages on there, what that actually is. That could be integrated into this unit as well. Anyway, for the new communication, we came up with this here. And this was, again, a collaboration between SEL and NEC Computers, I believe it was, and Paderborn. And was it NEC? Nixdorf. It was Nixdorf Computers. They came up with this. And this thing is still from a time when we actually made liquid crystal displays in Germany, in France, in England, and in the United States. But now there's only 2 countries left because of environmental regulations. That is South Korea and China, which are making them. And if they're ever going to stop supplying us, we're going to be knee-deep in trouble. And so this unit here came out with this when the new models were introduced into the market. The 600, the S500s, and the SECs until 93. So the first generation S600 would be S Coupe 600, and then the R129, and then the 202 models, and the 124 models when they did the Modellpflege. They all can be read with this unit, and I'm going to show you this now in this manual on how you can distinct if you have only blink codes. Now, I have this thing here for those with that 38-pin connector, and this is basically for these units here, because now you can actually just plug in your plus, you plug in your minus. This is the switched ignition, when you turn the ignition switch on and you're starting the car. And 4 is usually your ECU or the first control module you're gonna encounter depending on the list. And this is a pretty practical device to have if you want to do something else with it. Now, let me, what did I wanted to say now? Oh yeah, so this system here had a cable connector which brought all 40 cables or the 38 wires into this unit here. And let me show you this. Now, the way you know how this works is really simple. I'm just scrolling through here. So this is now the printout of the different pins, the pin configuration. And then it will tell you this here, you know, what is what module on what pin. And then it goes here into the different, you know, details about this code. And you can see this here. This was the unit I just showed you. This is this thing here, could be used. You can use the old impulse tester you're using for the, on the 126 on the V8s for the duty cycle setup. This is the connecting cable, and this is the actual handheld unit. They call it the HHT. That's what they, handheld tester. That's what they referred that to. And you can see this, so you can either plug in this unit here in conjunction with this here. This is what Mercedes-Benz used with the display. They didn't want their people to count the pulses. Or you can use this here. And then you have the old familiar X11 where you can do the pulse reading on it. They still kept the system because people were familiar. And then they show on how to actually hook this up with the 094 connector cable to the HHT. And then they had a special tester where you can do some other diagnosis. And I will get to that in a different video. So that is for the on-off ratio testers. Now, the diagnostic codes, what you're getting here is, now I have to zoom in. Let me see. They have displayed here, you can see this, that is the pulse tester. This unit here is on the left, and the handheld tester is on the right. And in this manual, you will see here, we're going to go through it. These are all your blink signals. So you go to the LHSFI control module, and now you have an option. You can either read out the blink code with the pulse counter, which would be this one here, or the digital one with the LC display, or the handheld tester, the HHT. And they're going through, and then there's some disclaimers in there, and you can see this. So for the blink codes, both units can read this. You see this here again is their pulse tester and the mushroom pin-out breakout connector. And on some of them, you're going to get single-digit codes now. With the handheld tester, you get 3-digit codes. And this is where the confusion came in. And you can see this, usually they coincide. So if this has 1, no fault, it doesn't show anything. A 2 is a 2. And on it goes. So unless we're getting to some specialized testing now, and I'm going to have to scroll through this document here a little bit. Yeah, and this is now the first one where we're doing a test prep for the DTC. This is for the CC control. That is the master controller in there. And now you can see this, they have broken this down. With the blink codes, you have only one code that is a 2, and 2, they have all these optional codes in the handheld tester. And this has, now the question is, how can this be accessed? Because you cannot access this with the push button pulse tester or pulse unit, or with the LC display one. But the handheld scanner, well, years ago, the people from Snap-on came out with a diagnostic tool beginning in 95 or 96, and that was called the MT2000. And the MT2000 had a long 4-line display, monochrome with no backlight, as that was pretty much standard back then. And this was the connecting cable for it. This is your 40-pin connector. I kept it. I had it when I had all the 600s in the mid-2000s because I had the MT2500. And this is their decoder. And what they're doing is now, you know that each one of these modules sits on one of these connecting pins. That means you have to move this. The CAN bus, however, has only one pin, and that is the K pin, what we're using for ISO 9141. So that is the one pin they have here, and since you have to plug this basically in, you have no way of actually physically connecting the handheld tester or the MT2500 or any of the new units manually to any of these cables. So what Snap-on came up with is what they called a personality key. And what this key does is all 38 pins come inside here into the circuit board. They're all terminated here. And this is a 40-pin connector. And they did a double-sided circuit board which you plug in, and they called that the personality key. And there were different numbers, S17, S18, S19. And what they would do is they route 6 modules per key out to this one pin or 4 pins, which is then selected internally for diagnosis one at a time. So whatever your group you're selecting, so it will tell you if you want to do the SFI left side, you have to plug in S21. And then you plug this in and you can do the right side, the left side, you can do the ignition modules, both sides. You can do the main controller, or you could do the, was it the airbag system? One other system was on S21. So whenever you selected this on the scanner itself, it will then internally switch this around to one of the 6 pins here, which that circuit board routed from here physically through the connector. It is basically a demultiplexer from 38 to 6. And because in essence what you need to do, you have to demultiplex this from the 36 possible pins, 35 possible pins. If you don't take the ignition key, the number 2 pin into consideration. Anyway, now the new systems, like the one I have from Martel, they require this kind of a connector. And with this, you can no longer select which module you're actually testing because it is pre-wired. So what they did here on this one, they routed to pin number 7, which is K. K is the data, bidirectional data pin, which is pin number 7 on an OBD connector, which is this one right here in the middle. That is the second one from the right. This is number 7. That's the K. And the corresponding low L is down here for 9141 ISO communications. Mercedes-Benz did not use the L connection. They used only the K connection. And so all data is transmitted. So now these people here, I bought this for $10 off Amazon. And what they did is a Chinese made one. They connected number 7K to pin number 4, which is now pin number 4. If you were to plug this into this unit, will give you access only to pin number 4, LH SFI, sequential fuel injection. And if we go back to the group sheet here, if this is a different model, then you can get either one of these here. So if you had a diesel, for instance, a 202 diesel, you get into the diesel system, distribution type, fuel. So whatever is installed on your particular model, it will route this through, and you cannot change this. So you would have to buy literally from the Chinese a cable made up for each one of the modules you want to test. The only good thing about this is they made this a screwable connector, which means you can open it and you could resolder the wire from terminal number 7 here, UK, to whatever module you want to actually connect. So I had people, I've read this, they said, oh, I bought all of this stuff and I plugged it in, it won't read, it won't communicate. Probably because the cable you got points to a different module than from what you want to read. So the best thing is to continuity test a cable when you buy them from the Chinese, and then figure out on which pin you're actually landing. And I got this now on 4, so I know that I will get anything that is on 4 with this particular cable, unless I'm going to do a breakout box with the rotary switch on it, and then I can move number 7 here to any one of the 35 pins, because 1 to 3 is really not that important. 3 is usually routed through, but not on OBD2, but it is routed through on the handheld terminal and on the MT2500, because when you start the car, or the system will tell you to start the vehicle, it will detect the key going into the start position, and or into the ACC position basically. And these systems here, they won't. Now the question is, how can you actually get into this, and how does this actually work? And this is basically as far as I want to take this today. So we have the multiplexing issue, and we have the issue with the, I'm going to draw something out here, and I hope this is going to work. It's going to let me. The multiplexing issue, and how you're going to come from the 35 possible pins to pin number 7. That's the only one you need to use for the new diagnostic tools. And if you can't read it, you have a mismatch because of pin 7 is going through a different module, and you would have to check your connecting cable from the 38-pin connector over to the OBD2 to see where pin 7 on the OBD2 connector actually goes to on the 38-pin connector. Then you will know, because it is fixed. If you don't want to test this, then you have to resolder this, or get another cable, or come up with another way. That's the advantage, and this is the reason why I will have to actually show this. I think this unit here had that big plug which came with it, and it went through. You can see this big wiring harness. Oops, you can see this big wiring harness here, and this would plug in. So this brings all 38 cables in there, and they had an electronic demultiplexer, so they could select any one of the 35 pins and the ignition switch, pin number 2, and route this however they wanted internally. That was the way they did it, and it was a very costly thing, because that test unit probably was around $10,000 or $15,000, as you see this in the picture here. This was not cheap. And the way this actually works between what we would call OBD1 is we have two lines. Here and here. And now the question is, we know from our handheld unit that when we push this for 2 seconds, that it actually will tell the module we're looking at or wanted to test that we want to test it. But how does the unit actually, the diagnostic units like this here, tell the module you want to test that you are ready for communicating? Well, that is pretty simple, and that is done with 5 baud per second. And in this case, it is 5 bits per second. Let me show you this here. This line here, when we start here, is our battery voltage. Battery voltage. So this signal here is volt, this is volt, and this here is the time, T, both of them. This graph here will be for the HHT, and this will be for the pulse tester, PT. So what we do here is we're going to go in 100 millisecond increments. 100. So this is 0. The unit always has a voltage on the test terminal. This is, again, the yellow ones here. Any one of the yellow ones always carry the battery voltage. And this is what we call here the wait state. Wait. This is where the modules, all modules, are waiting for something to be happening. So we have 100 milliseconds, 200, 300. I hope I have enough room, 400. Let's do it 200, 400, 600, 800, 1 second. Then we have 1.2, 1.4, 1.6, 1.8, and 2 seconds. So we know from our handheld tool that we have to push this for 2 to 3 seconds for this to actually start. And the electrical signal on this would be the yellow pin. Now drops down when we push it, and then it stays. We're pushing that for 2 seconds, and then we release it. It goes back up. Oops, I went a little bit too high. And it stays on until it actually starts to do what we're doing. Now we have the same timing down here. 400, 600, 800, and 1 second. 200, 400, 600, 800. 1 second, 1.2. Oops, 1.2 is here. 1.4 and 1.6 and 1.8. and 2 seconds. Now, the HHT does something similar to what we're doing with the push button here, but it does that electronically. And what this thing does, it brings out a signal in a 8-bit digit, and that is in hex 0x33, which is in, so this is hex 0x, which is in binary 50 in decimal 51. And digital, what this looks like it's a 0, 0, and then it goes to 1, 1. And then it goes to 0, 0, and then a 1, 1. So it turned it on for, this is the bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7. Yeah. 8 bits. We got it. And then it goes off. And this is how the control modules in these models here, and all the new models know what diagnostic tester is attached to it. And then it basically will stay on after here. It will be the control module now will respond to the signal that it has acknowledged the communication. And this is the reason why you can hook up only, you have to plug this in individually, because if they were all on the same bus and you sent this code out, then all 16 or 18 or whatever modules are in there, they're all going to respond at the same time. So you have to physically select this or electronically select this and talk and apply this signal here the same way you're doing it here, only to the individual module which you want to talk to or query or work with. And then what happens is this is at 5 baud per second. That is very, very slow. And 5 baud per second is 5 bits, 1, 2, 3, 4, 5. So you can see this, they're exactly 200 milliseconds long. And then once we have acknowledged the test unit will send a request over to change the baud rate to either 9600, this is the MB code, or to 10400, that is the ISO 9141 baud rate. So in order to talk to these older cars, you have to have a tester which communicates at 9600. If you have a tester which comes out at 10400, which is in full compliant with ISO 9141, that's not a nice 4, then you will have no communication. This is how this was worked out. And this is why this was basically a proprietary system until 95 with this model change. It was only the models then afterwards which are in compliance with 9141, which will switch to the higher baud rate at 10400. So this gives you an idea. Yes, all of these older models can be read. Yes, you have to physically select and make sure, and this is again on the OBD2 connector, pin 7, which is K. I do not know what K stands for in ISO 941, but this is the bidirectional data port which we're talking to in either instance here. And that K pin has to be routed to the correct module here between, this would be now from 4 to 38, depends on which one you want to query. If you check your diagnostic module, the one which you have for your car for the different diagnostic codes, see, you have ABS and ASR can be queried, but they don't have any particular, codes until you get here to these specific codes. And it is on these pages here, when you have this kind of stuff popping up, that's when you know that the module you're querying actually has the 3-digit codes, what they're commonly referred to, which is by far more enhanced than just getting a 2-blink code, which means it could be any one out of these 1, 2, 3, 4, 5, 6 different options you can't really read. And that is the challenge on those vehicles. Now, the Mercedes-Benz diagnostic system they're selling today, I'm not talking about the clone Chinese stuff, but the actual star diagnostic system they have, or Sentry, they have this in there, and they will correspond with these early cars exactly the way you need to. I have been thinking about this. I may do a low-cost version just for this year with a graphics LCD display in color, but this is going to be a lot of software, because all these codes you have here with the interrelation, first of all, you have to have the selectable. That means I have to have a 38-pin connector with a demultiplexer to do this electronically. So you choose your vehicle by VIN number, then the module you actually want to talk to, and then the sub-functions out of this code reading or live testing or resetting or whatever functionality is available. That is the biggest thing is to write all of the software up. Even when you write it in C, it is just gigantic because of all that data which has to be displayed. Every one of these error signals or codes you see here spelled out has to be incorporated into the software. That means it has to be run, I have to type all of this in. So when the computer brings in back error code, so you're displaying the error code or DTC, and then you can actually use the text and give the people the customer the same subgroup here where they need to look at, and that becomes pretty comprehensive electronically. It's not a big deal. You probably can have a unit like this built for a couple $100, $300. But the problem is the huge amount of cars and changes and the amount of data which has to be entered into this manually. This is an unbelievable time-consuming process. And if you get a software engineer, 2 software engineers in there, by the time this is all put into the microcontroller, to pull this up correctly, you're probably looking at 6 to 8 months of development time, and the average engineering hour or cost is about $150,000 a year in the United States. I could go to India and have it done there at a third of the price. Then it would cost somewhere around $50,000 to $100,000 to actually develop it, just because of the sheer amount of data which has to be incorporated in there. The microcontrollers today with external EEPROMs, they can hold 500 times, 50,000 times that data when you compile there out of the manuals. But the thing is, all of this would have to be compiled. So that's where the cost is. The hardware is basically next to nothing. It's in the software which would have to be developed. But I hope that this gave you an idea on how these two systems work, that you can get an enhanced code out of the early models from 91 or 92 on to 95, that they have it available, and it is not just the engine part, it is also the ABS and the ASR and all of the other subsystems except for climate. Whatever module can put out 3-digit codes will be more comprehensive, and there's more codes available, more specific codes as a result out of it. They have basically for each module 255 codes they can use, or deduct 10 out for special. That leaves you with 240 possible error codes on each module in 8-bit communication, and then live data feeding as well at either 9,600 baud or 10,400. This is one reason why these readers, these diagnostic tools are pretty slow, because the baud rate is still pretty low. Even if you go to 200 kilobauds, 200,000 bauds, that is only 200,000 bits. That is a very slow transmission compared to the internet, where you have transfer rates of gigabits and or megabits in the millions of bits, and we're talking 200,000 bits here per second. That is a pretty grueling, slow process. It's like a dinosaur moving through, and I'm talking about the latest models. That is where these codes are, the diagnostic systems are, either SAE or the ISO ones. That's basically the limit. Now to the next video, we're going to start talking about CAN bus, because if you can see this, even though the entire car is wired with CAN bus and every module sits on it, which communicates much faster than this stuff here, is you cannot access any CAN. You cannot look at the CAN data. You cannot look at the quality of the transmissions. You don't know how many error transmissions, collisions, lost packages, or anything is there, unless you actually hook something up to the CAN bus itself, because this is only the K communication of ISO 9141, or in this case the predecessor of it, And so we're going to start talking about CAN bus and CAN bus troubleshooting to see if these error codes here are actually valid or not valid. And with that, you have a great afternoon.